Hello, and welcome to our final presentation for our final project, Friction Testing and Machine by Fernando, Manuel, Armando, Roberto, and Joshua. In this video, our goals are to show the design, simulation, cost, and calculations of this project. In order for us to do this project, we have a set of goals and activities. In order for us to show you this, we use the Gantt chart, and we can see our activities that are the goals, investigations, design in SolidWorks, our first video, our assembly, our second video, our feedback, and finally our final report. We started in October 1st and we ended in December 4th.
As for the life of the system, the wearing life was calculated because of the constant friction and force to which the arrow will be subject. The bearing is component that will wear out the most. Then we have that way engine spinning at 1735 rpm. The pulley system is set up with diameter and 1 and 2 and revolutions 1 and 2. N1 by D1 is equal to N2 by 2 D2. So we have 2 and 1 is equal to 1859 RPM. D1 is equal to 30 millimeters. D2 is equal to 140 millimeters. So when we clear it, we have that N2 is equal to 398.357 RPM. If we want a year in hour, will be 8760 hours. The approximate load will be 400 libras fuerza. C10 is the classification of the catalog, so the formula will be like this. This gives us 2375.2131 libra fuerza or 10.5655 kilonewtons. With this value, we can select the bearing according to SKF catalog. For this is most support 10.5655 kilonewtons. Although the other diameter is 55.
Now, I'm going to explain about the design of our friction testing machine. We developed the prototype in SolidWorks software.
Regarding design, we have the following. We use a base to mount all the pieces. This base is made of 1 inch by 1 inch IAA material. We assemble two bearings to support the shaft where the bearing will be mounted to carry out the analysis, fixed to the base by means of two screws each. The shaft is a solid round 2-inch stick which contains a bullet at the one end, which serves to receive the motor moment. An 18-gauge sheet casing is used on the outside to prevent shaft accidents. We condition a 1200 RPM motor to move the shaft, which is bolted to the base. For the transfer of motion, we use two bullets and a belt. A nozzle sump and levers to apply force to bearing are used at the front. Finally, on the housing we have a power button for the motor and a voltage and amperage indicator.
We also created a motion simulation to demonstrate how it works. Shown below a small video. In this part, you can show the principle of the balance, because in one side we place the mass in the circular section and the other side the pressure is applied on the machine axis. One of our most important components is the engine. It generates movement in the pulleys. These are designed to reduce the revolutions at the input of the pulley because we have high revolutions, but at the exit we get a smaller revolution. In the housing of the system is shown as it fades with movement to the degree of being able to visualize the inner part of the system. That is, to be able to see the skeleton, bearings, and raincoats. The latter gives a better dynamic of a movement to the shaft. It should be noted that the shaft outputs contain a carter, which is the one that will store the lubricating oil.
Today I'm going to present the quotation of elements for construction of machine. The best option to build a new machine is bought pieces separately to reduce cost. We have three different codes. We have three different codes and options to buy piece for piece from different online stores. The first option is Mercado Libre Mexico. After consulting the price of each piece, the total cost is 6,864 Mexican pesos. The second option is AliExpress. The total cost is 3,511 Mexican pesos. And the last option is bought all the pieces in different online stores. The total cost is 4,222 Mexican pesos. We conclude the best option to buy all the parts is AliExpress, but the parts might take several weeks to ship.
Conclusion. The system for the friction testing are become more modern but also more expensive. So we understand that developing this project is a good idea to have technical and mechanical expertise. This project has allowed us to put into practice skills that we have acquired throughout our career: design, mathematical calculations, software simulations, etc.